You win some and you lose some, right? I don't know. Wasn't one of the best I've ever seen. It was exciting. Was it? I guess it was exciting in a way. But that's what it is. So we need to go through chapter 8 and do some problems. And we also need to prepare for a test, and I'll go through that at the end. I think I probably should do that at the end because there's not that many here. So we'll wait until more people show up, or you're the ones who get the benefit. Okay. So we'll go through some problems in chapter 8. And chapter 8 should not be anything new to you. It should be just a review of questions that you've had from EET 1020, and that's all you got to think about is how you did 1020, and you're all set. Yeah, I don't remember what problems I picked. I'll go back and look at the syllabus real quickly. The syllabus. Okay, so these are the problems that I put on the things that for you to try to hammer through. So this is what I thought, and I apologize for. I got out of the truck last night at 9 o'clock or 8:30, and by the time I got in and got home and got watching a little bit of the TV, it was past time to think about doing anything else. So anyway, we're here at okay. So here is okay. So these are the problems I want to look at: 13, 14, 17. 13, 14, 17, 25, 26, 33, 34, and 35. These are the ones I want you to at least take a look at and try to do. And we're going to go through some of these today. Okay, so that's, all right, let's go back. #13, 813. Find the equivalent impedance Z when omega is 2000 and express it in polar and rectangular. So I'm only going to ask you in polar. They ask you in polar and rectangular, but my concern is only in polar. Why? Because that's how you can convert in polar into the sine equation. So if you ever wanted to know sine something plus an angle, there is how that's done. So again, calculator time, 13. It's 10 ohms and then 20 millihenries, and then it's 20 ohms and 100 microfarads. So it's 100 microfarads. So what is the X sub L up here? It's 2 times pi times F times L, which is 2 times pi times F is omega. And omega is 2 times pi times F, which they give you. It's 2,000. So what is the X sub L up there? It's 2,000 times 20 times 10 to the minus third. So it's equal to what? 40. So this is 40, and what's the units? It's ohms, but there's a J in front of it. What about over here? 100 microfarads. It's 1 over J 2 pi F C, or minus J over 2 pi F C. So the 2 pi F is 2,000. C is times 100 times 10 to the minus 6, and that's in the denominator. So it's 1 divided by, parenthesis, 2,000 times 100 e to the minus 6, parenthesis. Okay. Okay, so let's do it again. 1 divided by, parenthesis, 2,000. 1 divided by, parenthesis, 2,000 times 100 times 10 e to the minus 6th. What does that equal? What do you get for that? Pardon? J5. It's a minus J5. Okay? So what do we have for the total Z? Z is equal to 10 plus J40 plus, now this and this are in parallel, so it is 1 over 20 plus 1 over minus J5. So can you do that all at once? Yes, you can. You can put that in your calculator, and you can get it in the complex mode, and you say 10 plus 20i plus 1 divided by, parenthesis, 1 divided by 20 plus 1 divided by minus 5i in parentheses equals, what do you get in polar for that? 18.94 at angle 53.84. Huh? Is that what you got? You got 87, 37. Maybe you got it right. Let me do it again. You got hers? Is hers? Okay. Let me try it again because I'm certainly capable of messing this up. 10, I want to get it, plus 40i 10 plus 40i plus 1 divided by parenthesis 1 divided by 20 plus 1 divided by minus 5i in parenthesis equals, okay, that you got it. It's 37.021 an angle 72.4. Is that what you got? Yeah, sorry about that. I can make them as well as anybody, but I went through and did it again, and that's what I got. So basically, that's good. Okay, can everybody do that? Can everybody go through and crank through and get that? Because that's the kind of question you're going to get from Chapter 8. Okay, this is called sinusoidal steady state analysis. If you've never heard that from me before, I've used it as a joke and all kinds of stuff, but that's what that is. This is using AC rules to basically find the impedance, and that's exactly how you do it. So that's the first one. 14 is the second one. We ask you this one. All right, so everybody got the idea, right? 14. Okay, so find the equivalent impedance here. So I don't care about all the other stuff. I just want you to be able to find, because now in this one they give you the they give you the impedances. They don't make you calculate them, and I will do that. Okay, I'll basically do that. So I'll give you a question more that looks like this from the point of view of, it may not be the same problem, but they will be J's and minus J's for the capacitors and inductors. All right? Okay, so this is number 14. How would you key this one in? Same way you did the other one, right? Make sure you've got it in complex mode. 50 minus 50i plus parenthesis 1 divided by 40, 1 divided by parenthesis 40 plus 100i in parenthesis plus 1 divided by minus 200i in parenthesis equals. Okay, option down. Ah, shoot, I did it wrong. One button is all it takes to push to mess this up. So anyway, go back and do it again. It's 50 minus 50i. Minus 50i plus 1 divided by parenthesis 1 divided by parenthesis 40 plus 100i in parenthesis plus 1 divided by minus 200i in parenthesis equal, and I got it wrong again. It takes me a while. Okay, 50 minus 50i plus 1 divided by parenthesis 1 divided by write it down. 1 divided by 1 over parenthesis 40 plus J 100 plus 1 divided by minus J 200. So it's 1 divided by parenthesis 1 divided by parenthesis 40 plus 100I parenthesis plus 1 divided by minus 200I in parenthesis equals, option down 1 equals. So did everybody get 210.5 at angle 26.7? Can everybody do that on a test? Any questions? Any comments? Can you do that? You got that? This is EET 1020 is all it is. 17. So this is a review, okay? When you say, what's left? Chapter 9. You can't wait, right? We talk about it and talk about it and talk about it, but chapter 9 is what's waiting for. That's why we're getting through this test now, because we've got to get to that in order to get this chapter. In order to understand chapter 9 thoroughly, you got to get to chapter 9, and in order to do that, we've got to blast through all this other stuff, which you've already had. So anyway, 17. And this is, what is equivalent impedance to this circuit? So this is another one, just like the other one. Okay, so let's do this one. Practice makes perfect, right? Right. So this one is, what is the Z of this one? So here's a J600. This is a minus J300. This is a J900. This is a 600. J600, okay, minus, okay, J900, J600, minus J300. So this is another one like the other one. So what is the impedance here? It is J600 or 600I. So you key it in as 600I plus 1 divided by, parenthesis, 1 divided by minus 300I plus 1 divided by, parenthesis, 900, excuse me, 600 plus 900I, parenthesis, parenthesis. Okay, see if that works. Oh, didn't do it right. So it's 600I plus 1 divided by, parenthesis, 1 divided by minus 300I plus 1 divided by, parenthesis, 600 plus 900I, parenthesis, okay. Still gives me an error. Okay, so we got to do it again. 600I plus 1 divided by, now this is parenthesis, 1 over minus 300J plus 1 over 600 plus 900J. Sorry about that. It's embarrassing, but, you know, we'll get there. I want you to understand that I'm doing the same thing that you're doing. 600I plus 1 divided by minus 300I. 1 divided by, no. 1 divided by parenthesis 1 divided by minus 300I. Plus 1 divided by parenthesis 600 plus 900I in parenthesis, in parenthesis. I'll get it. 600I plus 1 divided by parenthesis 1 divided by minus 300I plus 1 divided by well, I don't get, I think they give you an error because it's too complicated for the calculator. Is that, you got it? Okay. So did you do it just the way I did it by keying it in, or did you just do the part? Do you just this part and then you added that? Yeah, you added that. Okay. So does everybody understand that in the calculator, if you key this whole thing in all at once, it burps. But if you key just this part in and then add that, it works. You can get it to work. Yes, sir.
I would get it over with each part with negative more instead of
Okay. All right. Okay. Did everybody, what's your answer when you get that?
two.
Okay. 237 at what? 1.6? 71?
Yeah.
Okay, so did everybody see that by doing it the way I've done it, you can't, it'll burp in your calculator, but if you just do this, do this part and then add that, you can get it to work. So practice that. I, I don't know what I'm gonna ask, but I'm gonna ask something, and that's why we're doing these today, by hand, longhand. What else can I ask you? Well, let's go down here to 25, and this is where you start to get into the real circuits, but you gotta be able to do both. You gotta be able to do what we just did and this 25, 26 part. So this is, again, 25, 26 is, we're back to having to calculate the x sub c in this one. So 825, they have to give you a frequency. So what's the frequency? The 2 pi f is 1,000. So we use that. So our x sub c is equal to minus j over 2 pi f c, or equal to minus j over 1,000 times 2 times 10 to the minus 6th, or it is equal to minus j over 2 times 10 to the minus 3, or 0.5 times 10 to the third times minus j, or minus j times 500. So that's that. So now we've got a balance of 500 and 500 j, so minus j 500 j. So let's, and what do you use for your power or your voltage? You use the 20, okay? Now this is peak. But when you are given peak, you solve the question in peak. When you're given RMS, you solve the question in RMS, and you don't worry about it. Most of the time, um, this one is definitely in peak, but we don't care. We either solve it one way or the other based on what they give you, and this is all they do. So you solve it just like a DC problem. Now you want to know the voltage across, you want to know the current, and you want to know the voltage here and the voltage here. So what would be the currents? This is 500 and minus J 500. So what would be the current? I is equal to V 20 over 500 minus J 500. Okay, what would that be? No, it's just 20 divided by, parenthesis 500, minus 500 I in parenthesis equals option down 1 equals shift equals, it's 0.02828 at angle 45, or 28.28 milliamps at angle 45. All right, so that's about right because this is equal to this, and at 45 degrees, you're in good shape. Okay, so the other question you can ask is, do I have the angle right? Is current leading in a capacitive circuit, and you've got ice? Current leads voltage in a capacitive device, and in this case, the I is 45 degrees ahead of the V, because the V here is at 0 degrees. So this is a 0 degrees angle. This is at 45 degrees. Current is ahead of voltage by 45 degrees in this circuit, which is exactly what you'd expect. So if you check this out, you got the angle right. Okay, so that's another, did I go in the right direction? If you remember ice, you can remember that and you can check it out and it works. Okay, so that's that. Now you can solve for voltage if you want to. I don't really care. So basically, you got the problem cracked. Okay, so that's what you need. Now you can use voltage divider if you want to. It's up to you. At this point in time, I would probably just use I times R, I times X, and get my final value for my V. Okay, so number 26. I'm glad we ran into that because that problem with the one where you had to, the calculator does burp. It doesn't do everything. It's not perfect. So I'm glad we battled through that one. Or I kind of battled through it. How's that? Okay, so now we've got another one. In this case, we want to find the current and the two voltages, but we're given a magnitude and an angle. So you have to use that in order to get this thing to work. So it's 5 at angle 30. Now, is that really ever the case? No, you're never going to have this angle 30, but this is just for grins and giggles. They ask us to do this one. So this one is at 33K. This is at minus J 33K. And now you find the I in this case is equal to 5 at angle 30 over 33K minus J 33K. And again, you're going to find that, well, let's just look and see what we got. What is I? It's 5. Okay, so you say 5 at angle 30 divided by what? Parenthesis 33,000 minus 33,000 I in parenthesis equals, okay, option 1 down, answer. Okay, so this is equal to 0.107 at angle 75, okay. It's 0.1 milliamps at angle 75 degrees, okay? So again, current is ahead of voltage. 75 is ahead of 30 by 45 degrees in this case. Again, exactly 45 degrees. Okay, so what's the voltage across each one? Well, it's I times 33K is voltage across the resistor. I times minus J 33K is equal to the voltage across the capacitor, and you're done. Number 33. This is operating in the sinusoidal steady state. Again, find the steady state response, I sub x, and I sub x of, okay, so voltage, okay, so this is one where you have to find the voltage, then the I sub x, which is the current going out of this guy, so anyway. Again, they do not give you, in this case, the 2 pi f, so you have to calculate it. So you have to calculate your x sub c. So let's do that. So here we go with 833. The x sub c is equal to minus j over 2 pi f c is minus j over 250 times 0.2 times 10 to the minus 6th. Okay, so it is point times 0.2 is so it is 1 divided by parenthesis 250 times 0.2 in parenthesis. So it's equal to minus j 0.02 times 10 to the 6th, or minus j 20k. Any questions about that? So this is a minus j. Is that about right? Okay, so any questions about that so far? So now what is I? What is Z? Z is equal to 1k in parallel with parenthesis minus j 20k plus 2k, all right? So that is 1 divided by 1 over 1,000 plus 1 over 2,000 minus j 20,000. Okay, so let's do that. Let's see if we can get this one to work. 1 divided by parenthesis 1 divided by 1,000 plus 1 divided by parenthesis 2,000 minus 20,000 I in parenthesis equal. I got it. Proud of myself. Okay, so I got 993.86 at angle minus 2.82. Everybody get that? Okay, so now what is V? What is the voltage across the source? The voltage across the source is equal to 5 times Z, or equal to 5 times 993.86 at angle minus 2.82. All right, so that's a lot of volts. 5 times 993.86 is equal to 4969. So the voltage is equal to 4969. 4969.3 at angle minus 2.82. So now we've got voltage across the source. We've got, what do we need left? We need the voltage across the output, which is the voltage across this little piece over here. So basically, we know the voltage at this point. The voltage at this point is 4969.3. We do not know the voltage across here, but we can use voltage divider. You say, well, why don't we have to do with this? No, we can use voltage divider because we know the voltage here. We can use voltage divider around this loop. So the voltage divider, what is V sub x? 2,000 over 2,000 minus J 20,000 times the voltage across there, 4969.3 at angle minus 2.82. That's our voltage across V sub x. So there it is. Voltage divider 2000, which is this, divided by this plus this, which is this plus this. We know the voltage here, so we can go around this loop and say, what's the voltage across here? There it is. Any questions? Voltage divider is your best friend. All right, so you now have 2,000 divided by, parenthesis, 2,000 minus 20,000 I, in parenthesis, the whole thing times, whoops, okay, so I got to go back. Parenthesis in this thing. Times 4969.3 at angle 2.82 equals, option down 1 equals, it's 494.46 at angle 87.1, is that right? Anybody get that? Did anybody get a Vx of 494.4 at 87 degrees? Okay, so I got one yes. Everybody see how you did that? You're going to have to do this on Wednesday. Some of these problems, you're going to have to do a couple of these problems. Okay, 34 and 35. 34 is the same as 33, except you now have to do the V sub x here, which is no big deal because once you find this, you've got the V sub x there. So that's all that is. Okay, that's good. 35, that's it. Those are your last problems. Okay, so probably most likely have one like this. Ugh. So how do you do this? I want to know what V sub s is over there. How would you do this one? Well, I would. There's about half a dozen ways you can do this. One would be to write a voltage VB right here, which still doesn't give you the final answer, but it gets you close. It gets you the voltage here, and then you can use a voltage divider to get the final voltage. One way would be to Thevenize, and I think Thevenization is probably your best approach in this case because it's the easiest approach to get the voltage at this point, and then you can find the voltage at this point very easily. So that would be my suggestion. So Thevenize here, and then add this back in, or Thevenize here, and then add this back in. That'd be my suggestion, okay? Let's do that, because I think, okay, there's 2 or 3 ways of doing this. One would be finding the VB right here, finding the VB and then using voltage divider. That is one way of doing it. The other way is to Thevenize, and my gut would be to Thevenize it, cutting it right here. So let's find the V Thevenin. V Thevenin is equal to what? 100 over 100 minus J50 times 100, and that would give me my voltage. My voltage, if I were to cut it right there, it would give me my voltage. All right. So what would be V Thevenin? you're probably gonna hate me for this, but that's probably the way I would do it, okay? So, let's, 100 divided by parenthesis 100 minus 50I, parenthesis, but then I gotta multiply that by 100, so I should have said 100 times 100 divided by parenthesis 100 minus 50I. And parenthesis equals 80 plus 40I, option down, 1 equals, shift, it's equal to 89.44 at angle 26.56 degrees, or thereabouts. Any questions about that? All right, now, what is R Thevenin? R Thevenin is equal to 150 plus the parallel combination of the 50 and the 100, so it's 1 over minus J50 plus 1 over 100. So let's do that. Let's try this and see if this will take. 150 plus 1 divided by parenthesis, 1 divided by minus 50I plus 1 divided by 100 in parenthesis equals. It worked. So I get R Thevenin is equal to 174.6 at angle minus 13.24. So far, so good. So now I can reconstruct this whole thing and put my V Thevenin and my R Thevenin in here. And then I've got my final voltage out here, or excuse me, my final resistance at minus J150. And my resistance up here is 174.6 at angle minus 13.24. And my voltage is equal to 89.44 at angle 26.56. And I do voltage dividers. So it's minus J150 over this plus this times this. So Vx is equal to minus J150 over, and you say, can you mix polar and rectangular? In this calculator, you can. Okay, so it is minus J150 plus 174.6 at angle minus 13.24. The whole thing times 89.44 at angle 26.5. All right, so put that in there and see what you come up with. So we're going to multiply this thing out. Minus 150I times 89.44 at angle 26.56 times, times Ted. I lost it, okay. Minus 150I times 89.44 at angle 26.56 times, divided by, excuse me, divided by parenthesis minus 150I plus 174.6 at angle 13.24 in parenthesis equal. What is your answer? The answer for Vx is 66.266 at angle minus 30.52. Is that right? Everybody get that? Leo, did you get that? Or did you get something else? Okay. You didn't get that? Ugh. Well, the approach works, maybe the numbers don't work, but the steps work. Is that not the answer that they have in the back? I didn't look. There is an answer to this one. You got the same as yours first time, and it's not what I got? But you use the same approach? I, you know, as far as the quiz is concerned, quiz three, I was gonna look at it a little bit and you can hang on to it and hand it in on Wednesday, okay? As far as I'm concerned. I was gonna work on it next, all right? I was gonna work on it together so we can look at it a little bit. Um, so now that we're here, 4, 5, 6, 7, 8. I think we're down two. Are we down two because of weather, or are we down two because of two people that just said the heck with this? And this is, honest to goodness, this is the course, and you've been warned. This is the course that is just it's the one that never ends, and when you're done with it, you say, "Thank goodness I'm done." Okay, that's about the only thing I can say about it. Is this is the course. And this is the course that allow you to say that you have taken an engineering technology program as opposed to a technology program. If the word engineering were not applied, you would have to take this course. And because the engineering is applied, you have to take this course, or a course like it. Now, our former chairman said he had elements of this course in various courses that he had, which is a very famous way of saying we don't really have this stuff. But this is the course that kind of makes this an engineering technology program. I'm not lying. This is the one. Okay, so now you're fully invested in it. You're 5 weeks in, and we're ready to take test one. Tests come hard and heavy. There's no apology for it. This is just what you got to do. Okay. So now I'm going to go back and review. Okay. Any questions so far? So everybody knows that I've always pretty much settled on 10-point questions. That's 100 points. They're all equal in weight. So how do you build a test like that? 10-point questions. So honest to goodness, this is the way I do it. I look at what we've got so far, what we've done, and we basically skipped chapter 2, which we skipped chapter 1. We did a little bit of chapter 2, but we really talked about chapter 3, chapter 4, chapter 5, chapter 6, chapter 7, and chapter 8. Okay, so obviously there's going to be 2 questions from 1, 2, 3, 4, 5, 6, right? So there's 6 chapters. When you think about it for a second, well, 1, 2, 3, 4, 5, 6. You can't have 2 questions from each chapter. That's a good observation. So basically, uh, and so which ones you'd have 2 from chapter 3, which was basically this is your EET 10 course. This is your EET 10-20 course. All right. And chapter 4 is active circuits, which we really hadn't studied that much, but basically that's 1 and that's 1, and now it's chapter 6. And chapter 7, probably that. Now that's not a promise, but that's probably what we'll do. Now, what is so you now know the breadth of this, okay? So that's kind of gives you a little bit of an idea of what to study for. So, um, we hit chapter 6, so what was okay, so this one right here, this chapter 7, is kind of the bridge between ten ten and 1020. Okay, this is chapter 8 and 9 of your DC book. But I went back and talked about this in AC circuits. So again, this is your first order differential equation with one resistor and an L, or an R and a C. Okay, being able to spot those. That's chapter 8. Chapter 7. Okay, chapter 6 is on the derivative and the integral. So there would be one derivative and one integral. All right? Using V equals L di over dt, or I equals C dV over dt, or the integral version of these. And we did a bunch of these. I went back the other day and did a potload of these. So you can look at those and say, now which one? And you can bring, if you want your homework back, ungraded, you can have it. But I went over these in detail, okay? So really, there's nothing, so, okay, so these are 10-10 questions. This chapter 4, active circuits, this would be one question where you have like either a V or an I that is a multiplication of another one, and we'll do one of those, just one. Chapter 5 is a sinusoidal waveform. This is my U of t question, 1, all right? Build a waveform from, take the picture and write the U of t's for it, or take whatever. That's all that is. That's not hard, okay? Everybody follow that? So now you've got 2 questions from 10-10, which would be either Thevenin or whatever. I don't know. Maybe something else. Probably not. I don't know. Haven't looked at it that far. But chapter 3, chapter 2 is Thevenin or loop or mesh equations. Could be either one, but probably it could be Thevenin. Could be loop or mesh. I doubt if it's nodal equations. It might be mesh equations, but I doubt it. I don't know. Right now, I just don't know. Haven't written it yet. But that's the format of what we've got, and that's what you're going to have to do. Okay. 10 questions, probably half a page per question, so you'll have 5 pages in that one. Probably it. You have your full hour and 20 minutes, so be here at 8 o'clock. If you need more time, I will give you more time. We'll just take you downstairs, set you in the conference room, and you can work at it until noon, if you wanted to work on it until noon, okay? If anybody's got any questions, they can sit there and just kind of mull over it until they get so tired of looking at those questions. So I'll give you time. I'm not against giving you extra time, all right? But we've got to do this because coming in chapter 9 is the next phase, which is Laplace. And you got to know chapter 6 before you can do chapter 9. That's the bottom line. Okay, so let's go back real quick and look at quiz 3, because I think quiz 3 was, I don't remember what it was right off, but you do, because you, anyway, let's look at it and see what we got. right, so I don't leave you high and dry with this one if you're having trouble with it or whatever. I want you, this is a chapter, what? It's a chapter 7 problem? Yeah. So let's go back and look and see what we got. All right, so, all right. So what are we asking for in this question? What is this question about? This is a what? This is a DC question, right? This is a what? An AC question, okay? And what is this? It's an I don't know question, isn't it? So what do you have to do here? Kind of have to use ICE and Eli to figure this one out, okay? So I said it's for extra credit if you can figure it out. I don't really care. I'll never give you this on a test, but I might. This would be two problems, by the way. This would be one problem, this would be another one. I like this approach because what does this tell you? You have to switch your techniques, right? You have to switch from, what's the technique for this one right here? This is the exponential rise or decay, right? This is an exponential problem. What is this one? This is an AC sinusoidal steady state question, which is chapter 8 question. So you have to flip from, I call it the DC room and then the AC room. You have to flip your techniques from one to the other. So this is why this is, this is kind of a loaded question because it has both right in the same question. You have to think, now which way do I go? So basically that's all this question's about. So if you're doing this from DC land, this is, you have like a battery, and it's 50. You've got 330 up here. You've got 470 down here, and then you've got an inductor, okay? 1 Henry, okay? Now, how do you fix this? How do you figure this out? You've got to Thevenize it, because the only way that you can do the 1 minus e to the minus t over tau is with a Thevenized circuit. That's the only way you know how to do it, because it's been given to you. So basically you have to Thevenize it. So it's 470, so V Thevenin equal to 470 over 470 plus 330 times 50, all right? And then R Thevenin is equal to 330 parallel with 470. Then you reconstruct the circuit, and then you've got your V Thevenin, R Thevenin, and now you can find I sub L is equal to what? V Thevenin over R Thevenin, 1 minus e to the minus t over tau. Where tau is equal to L over R. And there's your question, there's your equation. That's DC. Everybody see that? That's a DC solution. That's a chapter 6 solution. Excuse me, that's a chapter 7 solution. Chapter 8 solution is what? Using this and then using this to find the x sub L, and then you can go back and do it, okay? Any questions? That's the A. B, the B solution is 50. And you got the same R Thevenin, V Thevenin. So it's the same R Thevenin and V Thevenin. It's exactly the same. But in this case, the 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 impedance of the inductor is what? J 2 pi, which would be in this case 500, 2 pi f times L, which is 1. So it's J 500, and you would solve for V across the you'd find V sub L in this case would be what? V sub L is J 500 over J 500 plus R Thevenin over times V Thevenin, and you're done. Okay, so what would it be for this last one? I don't know. How would you grapple with this last one? And I haven't done this, I have not tried to do this, but how would you grapple with? What do you know? Eli the Iceman, right? You know, everybody should know by now Eli and ice. V equals L di over dt. I equals C d V over dt. Okay, so what, now you've got V Thevenin and R Thevenin, and you've got an inductor. So what is voltage across the inductor? Well, it would be the change in I with respect to T, right? Voltage across the inductor. And what did they give you? They give you the voltage over here is 50 e to the minus 500 t. So it's going to be some voltage, V Thevenin, is V Thevenin e to the minus 500 t, R Thevenin, and then over here. This is V over here. So what would you, how would you find this? Well, I haven't worked this one yet. You have to struggle with it a little bit and try to find it. Anybody have any ideas? What? If you knew I through the L, what is I is equal to integral of V is 1 over L, 1 over L integral V dt, right? Which would be V Thevenin e to the minus 500 t. If you knew I sub L, then you could say the voltage through the inductor would be this minus the voltage across here, which would be the voltage across here. So that would be if you knew the I. If the I sub L, if you find I sub L, okay, so this would be my I sub L. If you find it, which is this, then you can say V inductor is equal to V Thevenin minus I sub L times R Thevenin. All right? and that would work. So if you took the integral of this, which is, what would be the integral of this? Well, it's v, it would be, uh, you work on it. I'm not gonna worry about it today. It's not worth it, but you can do it, and we'll work on this in chapter, yes, sir? Huh? Once you get R Thevenin and V Thevenin, um, you know, I don't know right off. It's, I is equal to the voltage across, but you don't know, you don't know this. You don't know this. And that's what, um,
For part A, not part C.
yeah, you don't know it in C, what the voltage across the inductor is. You know that the voltage across the inductor at t equals 0 is, um, is is this voltage. Okay, at t equals 0, it's this voltage right here, because there's no current. So there's no voltage across this guy right here. And you know at the end, all the voltage goes across here, because, well, I'd rather wait and do this problem in chapter 9, because this is a chapter 9 problem.
I was asking for, on part A.
Part A, I'm sorry. Part A, what was your question again?
Once you have R Thevenin and V Thevenin, how do you get VL?
Okay, in part A, you basically just use the, it's V source over R Thevenin, 1 minus e to the minus t over tau. And that's the standard equation.
And tau.
Tau is equal to L over R. That's the standard equation for that one. That's how you know, if you find a circuit that's got a DC source, okay,
Uh, would R
hmm?
would R be R Thevenin? It's
Yes.
Tau.
Yes, this is the R Thevenin, yes. Yep. So, for the one here where you're looking at Eli, is voltage is equal to L di over dt. So integral of the left is equal to the integral of the right. So I is, okay, so I 1 over L integral V dt is equal to I. So in this case, you're supposed to say the voltage, which would be the voltage Thevenin dt is equal to I. And then you can solve it. But this is really begging to be solved by chapter 9. So we leave it for chapter 9. Chapter 9 solves a lot of questions. It also raises a lot of questions. And we will spend an inordinate amount of time in chapter 9 working on Laplace. Okay? That's why I'm saying you can forget about C. And that's why, I don't know why he put it in there, but he did. Again, not to worry. You'll figure this stuff out in chapter 9. You've got it ahead of you. And we've got 2/3 of our semester to really grapple with chapter 9 and chapter 10. Those are the heart of this course. And that's why we're going to spend so much time on them. Any questions? Any comments? I'm sorry to put you in this position, but it's what we have to do. And that's why, you know, like I said, this is not an easy course. This is probably the hardest course for you. So just hang in there and study this stuff. You can have, don't bring a book, but you can have 5 or 6 sheets if you want them. You can have your homework back. If you want to keep all your quizzes and everything and then hand them in on Wednesday, that would be fantastic. Because I can sit here and grade them while you're doing your test. I don't have anything else to do to sit here and grade them. That'd be good. Any questions anybody's got? I think you know what's ahead, so please study. Take some time, go through these. Take care.